Good morning children. Welcome back to class 9 where we are learning Science and Technology part 1 and our lesson is work and energy. So in previous class we have studied about energy and we have seen kinetic energy and learned expression for kinetic energy. And today we are going to learn very interesting and important topic, that is potential energy. You must have seen Bahubali movie. Do you remember? On that movie, Bahubali was expert in archery. He had a unique technique to propel 3 bows at the same time. So let's see some examples. Let's try this. An arrow is released from a stretched bow. Water kept at a height flows through a pipe into the tap below. A compressed spring is released. Which words describe the state of the object in the above examples? The words stretched, kept at a height and compressed describe the state of the object. Where did the energy required to cause the motion of objects come from? The energy required to cause the motion of objects come from the energy stored in the system, that is potential energy of the system. If the objects were not brought in those states, would they have moved? No. Why so? The energy stored in an object because of its specific state or position is called its potential energy. Let's try this. Hold a chalk at a height of 5 cm from the floor and release it. Its speed is very less as it falls to the ground. Now stand up straight and then release the chalk. The speed of the chalk is much more as it falls to the ground compared to case 1. Is there a difference in the result of the two activities? If so, why? The difference is due to the initial potential energy of the chalk. The greater the initial potential energy, the greater is the final kinetic energy. So we can say that a chalk being held above a surface has a higher gravitational potential energy than a chalk near the floor. Now what is this gravitational potential energy? Gravitational potential energy is the energy in an object that is held at a vertical position. The energy is stored as the result of the gravitational attraction of the earth for the object.
So, from this we have understood that when two bodies, one lighter and another heavier, are dropped from the same height on a pit of sand, it will be found that the heavier body penetrates more in sand than the lighter body. Hence, a heavier body possesses more potential energy. If same body is dropped from different heights, we find that the body dropped from a greater height penetrates more. Hence, it has more potential energy. Potential energy of a body thus depends on the weight of the body. That is, W is equal to mg and height of body h above the ground. If it is found that the relation between potential energy, weight and height is equal to mgh. Now let's see the expression for potential energy.
Now we will see expression for potential energy. To carry an object of mass m to a height h above the earth's surface, a force equal to mg has to be used against the direction of the gravitational force. The amount of work done can be calculated as follows. You know the formula, work is equal to force into displacement. Here force is mg, displacement is h. W is equal to mgh. Therefore the amount of potential energy stored what we have seen, to carry an object of mass m to a height h above the Earth's surface, a force equal to mg has to be used against the direction of the gravitational force. The amount of work done can be calculated as follows. As we know the formula for work, that is work is equal to force into displacement. And here the force is mg and the displacement is h. So we will put the values here. W is equal to mg into h. Multiply it. So what will we get? W is equal to mgh. Therefore, the amount of potential energy stored in the object because of its displacement, that is potential energy, is equal to mgh. We know that work is equal to potential energy. So we will write here potential energy is equal to mgh. Therefore, we can say that displacement to height h causes energy equal to mgh to be stored in the object.
So, in this way, we have understood this expression for potential energy, which is EP is equal to mgh. So, remember this expression and the formula for potential energy.
Now we will see one numerical based on potential energy. 500 kilograms water is stored in the overhead tank of a 10 meters high building. Calculate the amount of potential energy stored in the water. I read it again. Listen it carefully. 500 kilograms water is stored in the overhead tank of a 10 meters high building. Calculate the amount of potential energy stored in the water. So let's see how to solve this numerical. See what we have given here. H is equal to 10 meters, M is equal to 500 kilograms and G is equal to 9.8 meter per second square. We know the formula. Potential energy is equal to mgh. Put the values. 10 into 9.8 into 500. Multiply it. We will get the answer 49,000 joule. Let's see it again. What we have given in the question, we have given h is equal to 10 meter, m is equal to 500 kilograms and g, which is gravitational constant, that is 9.8 meter per second square. We have learned the formula for potential energy, that is potential energy is equal to mgh. Now we will put the values in the formula. So mgh is equal to 10 into 9.8 into 500. Multiply it, you will get the answer 49,000 joule. Joule is the unit for potential energy. Ajay and Atul have been asked to determine the potential energy of a ball of mass m kept on a table as shown in the figure. What answers will they get? Will they be different? Let's see. What do you conclude from this? Potential energy is relative. The heights of the ball with respect to Ajay and Atul are different. So, the potential energy with respect to them will be different. Potential energy of the body with respect to Ajay is equal to mgh1 and potential energy of the body with respect to Atul is equal to mgh2. M is equal to mass of the ball. So we can say that potential energy is relative. Therefore, it depends on the values of h1 and h2. Hence, it will be different in the two cases.
So, from the above example, we have understood that potential energy is associated with the position of the object. Gravitational potential energy is the energy associated with the relative position of an object in the space near the Earth's surface. Now let's revise what we have learned today with the video.
We find energy in different forms. Energy of an object due to its position or arrangement in a system is called potential energy. For example, the work done in winding the key of a toy car is stored in the form of potential energy in it. This energy is released as the spring unwinds and sets the car in motion when it is left free on the floor. Further, consider the bow and arrow system. When the bow is stretched, the arrow gains potential energy. Another example is of water in a reservoir. This water has potential energy. This potential energy converts to another form of energy called kinetic energy when the water is released and can work to generate electricity.
So I hope you have understood today's topic. So for your assignment, you have to write down the definition of potential energy, which is your home assignment. Also, you have to write down the expression for potential energy and learn the formula for potential energy. And then we have studied one numericals. You have to note down it on your copy. Then in exercise there is the first question, write detailed answers. You have to solve A and B, which says explain the difference between potential energy and kinetic energy. We have studied both, so you can differentiate it easily. And then you have to derive the formula for the kinetic energy of an object of mass m moving with velocity v. We have studied this formula also, expression for kinetic energy. You have to note down that. Then there is a second question, choose one or more correct alternatives. So here are, for work to be performed, energy must be transferred from one place to another, or concentrated, transformed from one type to another, or destroyed. You have to note down the correct answer. And the second one is, joule is the unit of force, work, power. So correct it and write down it on your copy. Then there is a third question, rewrite the following sentence using proper alternatives. So here A, B, C, D, read it carefully, note down it and answer it. So see you at next video with next topic. Till then, keep learning, keep practicing. Thank you.